Hello everyone. Wish all of you are good and healthy. Today, inshallah, we are going to revise and summarize what you studied last week in grade 7 for math. We started by Unit 7, Lesson 1, which is solve one-step addition and subtraction inequalities. Then we started by revising what is an inequality and what do you know about it. So, inequality is a mathematical sentence that compares quantities. Inequality is a mathematical sentence that compares quantities or that compare between two expressions, which one expression is greater than or less than the other expression. Okay, can we connect to equation and let's compare and contrast between equation and inequality. Equation is a mathematical sentence also, but it contains an equal sign, while in inequality it contains comparison symbols like greater than, less than, greater than or less than or equal signs. So equation has an equal sign while inequality has comparison symbols. Okay, what else? Equation states that two expressions are equal, while inequality states that one expression is greater than or less than the other expression. Okay, this is first. Second, if we say, for example, Mr. I have x equals 5 and x greater than 5. What is the solution for each? If we talk about the solutions, here x equals 5, which means that x exactly equals 5. So you don't have any other solution. So in equation, you have only one solution. Okay, but if you compare to inequality, x greater than 5, x greater than 5. So if you suggest solutions or values for x, you will get that x can be 6, can be 7, can be 8, can be 10, and any number which is greater than 5. So you will get infinite number of solutions. You will get infinite number of solutions. So if we compare and contrast between equation and inequality for the number of solutions, we will find that equation has only one solution, while in inequality you have infinite or multiple number of solutions. Okay, so we stated the differences between both. What is the similarity? How they are similar to each other? Both are mathematical sentences, so both can contain numbers, operations, and variables. Also, both have two sides or two expressions. So whatever you do for one side, you have to do it to the other side. And this point will help us in solving. Okay, let's revise. How do we solve equation? For example, if we have this simple equation like x plus 2 equals 3, how to solve it? If you think about solving equation, directly you will think about inverse operations. What are inverse operations? Inverse operations are opposite operations that cancel each other. So the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. And the opposite of division is multiplication. So to cancel each operation in an equation, you have to use inverse operations. Okay, so let's do it. Minus 2 for both sides because subtraction is the inverse of addition. Then what will we have? In adding 2 minus 2, we will get 0 because they are additive inverses. So their sum is 0. So what is left on this side is x. Then 3 minus 2, which is 1. So we got 1. Okay, طب mister, can we change this equal sign and use, for example, any comparison symbol or convert it into an inequality? Let's use, for example, greater than or equal 3. Okay, then you will think, how can I solve it? It's not different than solving an equation. You can solve it as same as you solve any equation using inverse operations and getting the answers. So as same as you did on that side, you have to subtract 2 for both sides, then they will be cancelled. So what is left on this side is x. Then instead of writing equal sign, you will write the comparison symbol which is shown, which is greater than or equal 3 minus 2. Then x will be greater than or equal 1. Okay, so we got this answer. Okay, can you suggest some solutions for x? X can be 1 because we have equal sign. So because of this equal sign, x, it means 1 is included as a solution, so x can be 1. What else? X equals 2, x equals 3, x equals 4, and so on. So we have multiple number of solutions here. We have multiple number of solutions here. So as we compare between equation and inequality in solving, how can we solve inequality? We can use inverse operations and isolate the variables on one side, then suggest some solutions for the inequality after solving. Okay, then let's revise about how can we graph inequalities. How can we graph inequalities? So as you know, since last year, if you want to graph any inequality, first of all, you have to draw a number line. You have to draw a number line. You have to divide it into equal parts. Then you have to place a dot on the numbers, a dot on the numbers location. Okay, and here we have two cases. What are these cases? First of all, if you have the signs of greater than or equal, less than or equal, you have to use shaded dot. You have to use shaded dot because it means that this value is including in the solution of the inequality. Okay, while if you use or if you have the signs of greater than or less than, so you will use unshaded dot. You will use unshaded dot. Okay, then what will be the last step is to draw an arrow. Okay, how or in which side? To the right or to the left? It depends. Also, we have two cases. The first case, if we have greater than or equal. The other case, if we have less than or equal. In a greater than or equal, take the arrow to the right, because as much as you go to the right of any number line, the numbers are getting larger. While if you have less than or equal, take the arrow to the left, because as much as you go to the left of the number line, the numbers are getting lesser. the numbers are getting lesser. Okay, then at the end, if you want to check your answer, you can check it from the graph. How? Let's take an example. For example, if you want to draw the, or for example, graph n greater than -2. So first of all, you have to draw a number line. Then you have to divide it into equal parts. What do you mean, mister? It means that you have to divide it into equal steps. So, for example, one by one, so 0, 1, 2, 3, and so on. Or two steps by two steps, so 0, 2, 4, 6, 8, and so on. But, mister, can I divide it, for example, like 0, 1, 3, 7, 10, 100? No, of course not, because you didn't divide it using equal steps. So, here, let's divide it one by one. So 1, 2, 3, 4. On the other side, we have -1, -2, -3, -4. So we drawed the number line. We sketched it already. Then we have to place a dot in the location or on the number location, which is -2. So go for -2 and plot a dot. Okay, and you have to check the sign. If you have equal sign, for example, greater than or equal, less than or equal, you have to use shaded dot. So here we have greater than only, so we will use unshaded dot. Then it's greater than, so take the arrow to the right, because as much as you go to the right side, the numbers are getting larger. So this is the graph of inequality. This is the graph of inequality. Okay, so to sum up the ideas that we have in this lesson, we have to solve one-step addition and subtraction inequalities. Then we have to graph the solutions that we get. How do we solve? Let's go for first question. So we have to solve and graph each of the following. Let's go for example 1. H minus 5 less than 5. So here I have to solve it, then I have to graph it. Okay, because we have subtraction, so the inverse of subtraction is addition. So I have to add 5 for both sides. Then they will be cancelled. So what is left? H less than 5 plus 5. So H less than 10. Okay, so I solved it. I have to suggest some solutions for H. So any number which is less than 10 is a solution. So H can be 9, H can be 8, H can be 0, and so on. Okay, now let's graph. Plot a number line or sketch a number line. Then, Mr. Can I walk 5 by 5? Yes. Can I walk 10 by 10? Yes, it works. Can I walk 1 by 1? Should I start by 0? No, you can start by any number that you want. So I will graph it by two ways. For example, 0, 5, 10, 15, 20. On the other side, -5, -10, -15. I want to use another scale. For example, I want to start by 5, 6, 7, 8, 9, 10, 11. Both of them are correct. So you can use your scale and start from wherever you want, any number. Okay, so let's go for the shown number, which is 10. Place a dot because we have here less than only, so it will be unshaded. Then because it's less than, so take the arrow to the left. As same here, go for 10, place unshaded dot and take the arrow to the left. Okay, now let's go for the last step, which is checking. If you want to check your answer, you said that h can be 9. So here you will find it 9 is included, 8 is included, 7 is included. All of them are less than 10. So your answer is correct. Okay, so your answer is correct. Okay, let's go for another example. Let's go for another example. Example 2. B plus 10 greater than or equal 5. So here we have addition. So the inverse of addition is subtraction. So minus 10 for both sides. Then what will we have? This is will be cancelled. B is left on this side, greater than or equal 5 minus 10. And to subtract any two integers, you have to apply the rule of KCC, or keep change change. So b greater than or equal 5 plus negative 10. So here we got different signs, so we have to subtract them from each other. So 10 minus 5 is 5. Then check the sign of the greatest number, which is 10. So it will be negative. So b greater than or equal negative 5. Then if you want to suggest some solutions for b, so b can be negative 5 because here we have equal, so this value is included. B can be negative 4, b can be 0. Okay, and so on. Right. Let's now graph. Okay, Mr. We have negative 5. Can we walk one by one? Yes. Can we walk 5 by 5? Yes. Any scale you can use it. So, for example, 0, here 5, 10, 15, negative 5, negative 10, negative 15. Then place a dot in the location of negative 5. Okay, Mr. Will it be shaded or unshaded? Because here we have the equal sign, so it will be shaded. So it will be shaded. Then, because it's greater than, so you will take the arrow to the right. Because as much as you go to the right, the numbers are getting greater. Okay, does it mean if someone sketch if someone sketch it like this, for example, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, then he will place it here, shaded dot, then take the arrow to the right. Is it wrong? Of course not. It will be also true. So you can choose your scale, your own scale. Okay. Now, if you want to check your answer, so is it in the domain negative 4, negative 3, 0? Yes. So your answer is correct. Your answer is correct. Okay. Let's make it harder. Let's take an example using decimals. Example 3. We have, for example, x plus 2.6 greater than 1.2. Okay, let's solve it. It's addition, so use subtraction. So subtract for both sides. Then they will be cancelled. So what is left is x greater than 1.2 minus 2.6. as same as we said before, that when we subtract two integers, we are going to use keep change or KCC. So x greater than 1.2 plus negative 2.6. So x greater than negative 1.4. So if we want to suggest some solutions for x, so negative 1.1, negative 1.3, negative 1, 0, okay, and so on. Okay, let's graph it. Let's graph it. Okay, because it's an even number, so we can walk 0.2 each time. Or maybe we can walk 0.7 each time. Or I can start from negative 1.5, negative 1.4, negative 1.3, and so on. So I'll draw it by different scales, and feel free to choose any one of them. For example, 0, then 0.7, 1.4, 2.1. On the other side, negative 0.7, negative 1.4, negative 2.1. Then place the dot, and it will be unshaded because no equal sign. So unshaded here. Then because it's greater than, so you are going to take the arrow to the right. Okay, so this is first. Second, sketch. What can we do? For example, negative 1.4, negative 1.2, negative 1, negative 0.8, negative 0.6, negative 0.4, negative 0.2, 0. So each time we walked by 0.2, place here unshaded dot, take the arrow to the right. It's also true. Okay, what else we can use? We can say that negative 1.4, negative 1.3, negative 1.2, negative 1.1, negative 1, negative 0.9. Each time you walk 0.1, place it on negative 1.4 and take the arrow to the right. Then, if you check, you will find that all the answers that you should suggest are correct, so your answer is correct. Okay, then let's make it harder and use fractions. Let's make it harder and use fractions. Let's go for another example. Example 4. For example, x plus 2 over 3 greater than or equal 1 over 3. So because it's addition, so minus 2 over 3 for both sides. Then they will be cancelled. So x greater than or equal 1 over 3 minus 2 over 3. And we will find that they are like fractions. They have the same denominators. So apply the integers rule directly. If you subtract two integers, you will apply the rule of subtraction of two rational numbers. So if you have like fractions, so directly apply KCC. So x greater than or equal 1 over 3 plus negative 2 over 3. So different signs we have to subtract. So 2 minus 1 is 1 and denominator does not change. Then keep the sign of the greatest number, which is negative. So x greater than or equal negative 1 over 3. So x can be 0, 1 over 3 or any positive number. Then let's graph. If we divide 1 into 3 parts, so each part will be 1 over 3. So we can start by 0, then 1 over 3, 2 over 3. Then when you reach 3 over 3, it will equal 1. As the same on the other side, negative 1 over 3, negative 2 over 3, then negative 3 over 3 or negative 1. Okay, now place a dot on the location of negative 1 over 3 and it will be shaded because of equal sign. Then because we have greater than, you will take the arrow to the right. So this is the graph of this inequality. Then if you check the answers, you will find it true. So x equals 0, 1 over 3 or any positive number. So your answer is correct. Okay, let's give another example. But here, for example, if you have the variable on the left side, not on the right side. For example, negative 2 less than or equal x plus 4. At the beginning, some of the students will solve it normally. Okay, minus 4 minus 4, then x less than or equal negative 2 minus 4, and they will complete normally. Okay, but this is totally wrong. This is totally wrong because they switched between the two expressions and this is wrong. So what should they do? Okay, guys, first of all, if you find it on this side, on the other side, okay, on the right side, you can rewrite it again to avoid making any mistake. How? Mister, let's convert between them. Or, sorry, let's switch between them. Let's rewrite it again. So here we have x plus 4. If I write it from right to left, I'll find that x plus 4 greater than or equal negative 2. So greater than or equal negative 2. So now I can solve it. Okay, we can have another example. For example, negative 6 greater than or equal y plus 2. So you can rewrite it again. How? Y plus 2, read it from right to left. Y plus 2 less than or equal, okay, negative 6. Then solve it normally as same as before. Okay, so let's go back for our example. Okay, we have negative 2 less than or equal x plus 4. So let's rewrite it again. So x plus 4 greater than or equal negative 2. So let's solve it normally. We have addition, so minus 4 for both sides. Then they will be cancelled. So x greater than or equal negative 2 minus 4. Then, because we subtract two integers, so keep, change, change. So x greater than or equal negative 6. Then, if you suggest some solutions for this, so x can be negative 6, negative 5, negative 4, and so on. Then we can graph it 0, negative 2, negative 4, negative 6, 2, 4, 6. Place a dot on negative 6, make it shaded because we have greater than or equal, and we have greater than or equal, so take the arrow to the right side. So it's true. Okay, let's go for example 6. Negative 6 less than or equal y minus 2. Okay, or let's change less than or equal. Let's make it x greater than or equal y minus 2. So let's read it from right to left. So y minus 2 less than or equal negative 6. So we rewrite it again. Then we have subtraction. So add 2 for both sides. So y less than or equal negative 6 plus 2. And we have different signs. So we subtract. So it will be 4 using negative sign. So if I suggest some solutions for y, negative 4, negative 5, negative 6, and so on, then you can graph it on a number line 0, negative 4, negative 8, negative 12, 4, 8, 12. You can place the dot on negative 4 and it will be shaded, and because you have less than, so take the arrow to the left, or you can use another scale. Start from negative 4, negative 5, negative 6, negative 7, negative 8, and so on. Then place the dot on negative 4 and take the arrow to the left. Both are correct. So this was our lesson for last week. So to sum up what we studied in this lesson, we studied about inequalities and how to solve inequality using inverse operations. And we use inverse operation to isolate the variable on one side and getting the answer. Then we revised how to graph an inequality on a number line. So this was our lesson for today, or this was a revision for what we studied last week. And thank you so much. Have a nice day and goodbye.